Today is day 4 of graphing rational functions. I know you guys are probably all tired of it, but it is still something we need to be able to do as we get ready to graph other types of functions. So we're going to do about 3 or 4 examples, and then you will have your assignment. So it still asks for discontinuities, holes, vertical asymptotes, x-intercepts, horizontal asymptotes, and the domain of each. So over in our list, it doesn't necessarily say x-intercepts, so we're just going to make one down here for when we are solving. Step 1 is to factor. So in the top, we have x cubed and 16x. Well, x cubed and 16x have an x in common, so we're going to pull an x out. And we now have x times x squared minus 16 in the top. In the bottom, 4x squared minus 8x, well, my 4 and 8 have a 4 in common, we can pull it out, and x squared and x have an x in common. So we get 4x times x minus 2. We can still factor the top, we have that squared up there. That is a difference of squares. So I'm going to rewrite everything aside from the x squared minus 16. When breaking up a difference of squares, we take the square root of the first part, which in this case is x squared, and the square root of the last part, which is the 16. So square root of x squared is x, square root of 16 is 4, and we give one a plus and one a minus. From here, we factored everything that we can. There's no more numbers to pull out in common, no variables to pull out, anything like that. So we're going to cross out what we have in common in the numerator and denominator, which would be the x right here. It's in top and bottom. And we are left with x plus 4 times x minus 4 all over 4 times x minus 2. So there's our factored version of number 1. From here, we're going to go ahead and find the x-intercepts, even if it is a little bit out of order. So to find x-intercepts, we set the numerator, the top part, equal to 0. I have 2 pieces. I'm going to set both pieces equal to 0 and solve them for my x-intercept. So for the first one, we're going to subtract 4 from both sides, and we get x equals negative 4. For the second one, if we add 4 to both sides, we now get x equals positive 4. And when we write intercepts, they must be in the form of a point because we're going to put them on our graph. It helps us. So we know the x values of our intercepts, and the y values are going to be 0. So our 2 intercepts are negative 4, 0, and 4, 0. Next, we want vertical asymptotes. Vertical asymptote says we set the denominator equal to 0. Well, our denominator is x minus 4 times x minus 2. So this 4 isn't going to really change much. If we divide both sides by 4, it gives us a 0. So x minus 2 equals 0. Add 2, and this tells us that x equals 4. Now remember that your asymptotes will be written as equations, so vertical is x equals, horizontal is y equals. A hole occurs if we had a common factor in the top and bottom, so in the numerator and denominator. In this case we did, that was our x. So for the hole, we take what we crossed out and we set it equal to 0 to find the x value. In this case, that is just 0. In order to find the y value, we take that answer and we plug it into the simplified version, which means we need y equals 0 plus 4 times 0 minus 4 times 4 over 0 minus 2. Well, the zeros don't really change anything. All my numbers are pretty much staying the same. Y equals 4 times negative 4 on the top, which is negative 16, over 4 times negative 2, which is negative 8, and this is positive 2. So there is our hole. Next, we need a horizontal asymptote. So this goes back to the original problem. I want to look at the highest degrees. Degrees are exponent. So the highest exponents, that's our degree. Well, I've got a 3 on the top and a 2 on the bottom. So if we are bigger on top, then we do not have a horizontal asymptote. And then domain, so domain is based on our vertical asymptote and the whole. Okay. So first I realized earlier I wrote down x equals 4 for I think the vertical asymptote when it should be x equals 2. Okay. And then we're going to go ahead and start graphing this. So first I want my x-intercepts, which was negative 4, 0, 4, 0. From here, I want to add in my asymptote, which is x equals 2. I'm going to find 2 and make my dashed line through it. Next, we want to go ahead and put the whole in. So the whole is at 0 for the x's, up to 2 in the y's, and we're going to put an open circle over it. Because a whole is a break in the graph, it means we're not actually using those points. And then from here, we're going to connect and follow along the asymptote. So if I look, these two connect very easily. Flow up here. And this one brings me this direction. It kind of tapers off towards the end of the graph. So on the other side, I'm going to kind of follow the same pattern. So I want to trace along the asymptote as close as possible, and then slide off the other side of the graph. Once again, if you are not sure if your graph looks correct, you can always plug in the original problem into your graphing calculator, or on Desmos if you don't have a graphing calculator if you're at home working, and it will give you an image similar to this, but the holes will not pop up on a graphing calculator. Keep that in mind. So you'll have just the shape of the graph that you need, but the hole will not pop up on the calculator. So now let's try number 5. Still following the same routine. Once again, we're going to add in x-intercepts down here. So first we want to factor. Well, in the top, I have x cubed plus x squared minus 2x. They all have an x in common. We're going to factor it out. And now everything is 1 less x. So x squared plus x minus 2. In the bottom, I have negative 4x squared plus 36. If I have a negative in the front, I definitely want to factor that out. And 4 and 36 have a 4 in common. The negative is going to change the sign. So instead of negative x squared, I have a positive x squared. And instead of a positive here, it's negative. 36 divided by 4 is 9. In the top, this is just a regular quadratic that we want to factor. We're multiplying to get to negative 2, adding to get to positive 1. So that's going to be x plus 2 times x minus 1. And then in the bottom, we still have negative 4. That x squared minus 9 is another difference of squares. So square root of the first part gets us an x, square root of the second gets us a 3, and then a plus and a minus. Unfortunately, this time it looks like we can't cross anything out. So I know I'm not going to have any holes. I can go ahead and write none. And now let's go ahead and make our way sort of around the list. Once again, we're going to start with x-intercepts. X-intercept says set the numerator equal to 0. I have 3 things in the numerator. So I'm going to say x equals 0. And that one's done. X plus 2 equals 0. Subtract 2, subtract 2. This is x equals negative 2. And then our last one, x plus 1 equals, x minus 1 equals 0. Add 1, x equals 1. Remember when we write our x-intercepts, they are all points, so we have 0, 0, 0, negative 2, and 0, 1. Those are 3 x-intercepts. Next, vertical asymptote. That says we take the denominator and we set it equal to 0. Denominator says negative 4 times x plus 3x minus 3. Our negative 4, just like last time, our outside number didn't change much. We're just worried about where the x's were, so we're going to say x plus 3 equals 0. And if we subtract 3 from both sides, we get x equals negative 3. And then x minus 3 equals 0. And add 3 to both sides, and we get x equals positive 3. So there are 2 vertical asymptotes. Let's again write them as equations, so x equals something. Onto horizontal asymptotes. Horizontal says I want the degree of the numerator and denominator from the original. Well, my highest is a 3 and a 2. Once again, bigger on top means none. And then this time we are going to do discontinuities first, and then we'll get the domain from drawing so you can kind of see where we get all of it from. So discontinuities was holes and vertical asymptotes. Well, I only have vertical asymptotes this time. So the discontinuities are negative 3 and 3. So first, let's go ahead and put our vertical asymptotes of negative 3. So x equals negative 3. X equals positive 3. Next, let's put our 3 x-intercepts down. So we had 0, 0, 0, negative, sorry. As I realized, I wrote both of these intercepts backwards. So negative 2, 0, and 1, 0. And now we're going to connect and follow as best as we can. So I know these 3 have to be connected. They kind of just make a line. And then I have to follow along the asymptote. So these are going to curve up. And then the other one will curve down as I draw on the asymptote. So don't draw on the asymptote. Draw as close to it as possible. Okay. So there's the middle section of our graph. Now, I don't know if I have anything anywhere else. But I could test a couple of points. So I'm going to pick the positives because I don't want to work with negative numbers. It'll give me an idea of what the graph should look like in this side so I can mirror it on the other side. So we're going to try plugging in 4 and plugging in 7. So I want f of 4. And I'm going to plug it into the original. So everywhere we see an x, we're going to put a 4. So the top says 4 cubed plus 4 squared minus 2 times 4. And in the bottom, we'll have negative 4 times 4 squared plus 36. And if we plug this into our calculator, so hit Control Divide in order to get the fraction symbol, and then we'll just type it in as you see it with exponents and parentheses. This is going to get us negative 18 over 7, which is equal to negative 2.57. So when x is 4, I'm somewhere down here, negative 2.57. And then I'm going to try one more point. I'll do, like I said, 7. I'm going to do the same thing. I'm going to plug in 7 for all of the x's. 7 cubed plus 7 squared minus 2 times 7 all over negative 4 times 7 squared plus 36. So if I take this and plug it into my calculator, exact same thing, control divide, plug it in parentheses and exponents and all. This gets us negative 2.36. So I'm kind of floating somewhere above this point. Just a little bit higher. These aren't perfect points, that's fine. So it looks like these are connecting kind of this way, and they curve down along the asymptote. So on the other side of my graph, I'm going to mirror that kind of look. I'm going to follow here, and then I'm going to curve this way. And there is our graph. So we're going to do one more example. Let's do number 11. Okay, so same kind of thing. I'm still looking for all of the same information, including x-intercepts. We're going to write it at the bottom again. Oh, I didn't do the domain for the last problem. Let's go back up real quick. So domain for this one, once again, it's based off of our asymptotes and holes. So if I follow along, I'm starting at negative infinity. The first break in the graph comes from this this asymptote right here, which is negative 3. We're going to pick up on the other side of negative 3. The next break we reach is the other asymptote of 3. And then we pick up at 3 and continue all the way to infinity. There's our domain. So one more problem. Number 11. So factor first, and the top, once again, this is another x cubed, so I know we have to pull out an x. And we get x squared plus x minus 12. And the bottom, once again, another negative. I'm going to pull it out, and 4 and 8 have a 4 in common. And then I can also pull an x out of this one. So I get x minus 2. In the top, we still have to factor that quadratic. So I'm going to write everything else besides that. And then to break up our quadratic, I need two numbers that multiply to get us negative 12 and add to positive 1. Well, that would be plus 4 and minus 3. Intercepts, we're going to set the numerator equal to 0. Oops. First, cross out things in common. Sorry. So x and x are gone. And now we're going to set the numerator equal to 0. So we have x plus 4 equals 0. And x minus 3 equals 0. If we solve both of those, we're going to get that x is equal to negative 4 and x is equal to positive 3. Once again, make sure you are writing the intercepts for your x-intercept as points. So I'm going to have negative 4, 0 and 3, 0. Put them down. Next, vertical asymptotes, set the denominator equal to 0. So I'm going to take the x minus 2, because once again that 4 on the outside won't change us, and solve it. Add 2 to both sides. So x is 2. I'm going to go ahead and put that asymptote in there. Next, are there any holes? Well, we crossed out an x, so we're going to set x equal to 0. There is our x value. And then we have to take it and plug it in. 0 plus 4 times 0 minus 3 over negative 4 times 0 minus 2. Zeros don't change much, so on the top I just really have 4 times negative 3, which is negative 12, over negative 4 times negative 2, which is 8. And this is going to get us negative 2/3. Not that one. Sorry, if I simplify by 4, it should get me negative 3/2, which is negative 1.5. So there is our y value. For the whole, I'm going to find 0 and then negative 1.5, and I'm going to put my open circle. Horizontal asymptotes, I want the degree of top and bottom, 3 and 2, so bigger on top, it is none. And then domain, we're going to use our asymptote and whole. So we're going from negative infinity to 0, union 0 to our vertical asymptote, which is 2, union 2 to infinity. And for discontinuities, we just need the x from the whole and the vertical asymptote. So now we can draw this. Well, I know from my whole to the asymptote, I'm going down. Connect the other way, I kind of curve up. And I'm going to follow the same kind of direction on the other side. So there is our graph. For this assignment, you do have the evens to work on. Make sure you put your name on all of these sheets of paper and turn it into Canvas when you are done so you can receive a grade. And we will see you tomorrow.